Naming in organic chemistry. But before we can name organic chemicals, first we need to know what makes a molecule organic or inorganic. Organic compounds are those that contain carbons bonded to other carbon atoms and hydrogen atoms. Organic compounds may also contain halogens like fluorine or bromine, oxygen, nitrogen, sulfur, and phosphorus. All other compounds are inorganic. Today I'm mainly going to be talking about hydrocarbons. These are compounds that only have carbon and hydrogen. There are 5 kinds of hydrocarbons: alkanes, alkenes, alkynes, cycloalkanes, and aromatic hydrocarbons. And now we can go into the naming. Alkanes are hydrocarbons that only have carbons single bonded to each other. They have no double or triple bonds, meaning that they are saturated with hydrogen, so you can't add any more to them. The naming of these alkanes and pretty much all of these hydrocarbons is based on using Greek prefixes to show the amounts of carbons in the compound or chain, followed by the appropriate suffix, ane in this case. For an example, this compound has 1, 2, 3, 4, 5 carbons, so it is pentane. Now, knowing that the naming is based off of prefixes, some of you may be surprised to learn that CH4 is not called monane or unane or just ane, but is instead called methane. This is because the prefixes for 1 through 4 are not the expected mono, bi or di, tri, and tetra, but are instead meth, eth, prop, and bute. And also, I'm just going to put 9 here, because I know there's some nerd out there who, like me, knows that the Greek prefix for 9 is enea. It is not. And if you write that, you'll get it wrong. It is actually non, which is Latin. So instead of using eneane, it would be nonane. Like that. I've removed the hydrogens for simplicity. But as you can see, this hydrocarbon has a branch. How would you name this? So the first step is to find the longest chain. In this case, there are 1, 2, 3, 4. That is the longest chain. This is called our parent chain, so it would be butane. You can also count it like this, 1, 2, 3, 4. It'll give you the same, or like 1, 2, 3, 4. Just don't count it 1, 2, 3. That is not the longest chain. Next, after you found the parent chain, you want to find the number of carbons in each branch. These are called the alkyl groups. For simplicity's sake, I've only put 1 here. This is 1, so it would be meth. When naming the alkyl groups, add the YL suffix to show it's a branch of the parent chain. So this would be methyl. Next, you want to find how many carbons the branch is from the end. You want to use the smallest number possible for this. So here it could be 1, 2, or it could be 1, 2, 3. So you want to use the lower number, which is 2. 1, 2. Finally, you want to put all of this together. So you put the number that we just found in front of the alkyl group name and add a hyphen to connect them. Next, we put that all in front of the parent chain name without a space. So this chemical is 2-methylbutane. There is no space here. And there's a hyphen here to connect them. Now, what if there are multiple kinds of chains, like in this compound here? If only one kind of alkyl group appears multiple times, add a prefix to indicate so. Di, tri, tetra, etc. Those ones. Next, list all of the branches' positions separated by a comma. An example of this would be 4,5-dimethyl, whatever the parent chain is. This compound also has an ethyl branch, though, over here. To find out what order you would list the branches in, you should list them by the alphabetical order, not including the di, tri, etc. prefixes. So just going through it really quickly here, this has 7 carbons, 1, 2, 3, 4, 5, 6, 7. So the parent chain is heptane. We have 2 methyl chains at positions 4 or 5, or positions 3 and 4, depending on how you're counting it. I'm going to count it like 4 and 5. And finally, there's 1 ethyl chain at position 3. So combining it all together, we want to list ethyl before dimethyl. So we get 3-ethyl 4,5-dimethyl heptane. That was essentially the basic naming of hydrocarbons, but hydrocarbons don't just come in chains. They also come in rings. Those would be cycloalkanes. They're like alkanes, but they come in a ring shape. The naming rules for them are the same, you just add cyclo in front of them. For these three examples, they would be cyclopentane. This one would be 1,4-dimethyl-cyclohexane, and this would be 1-cyclobutyl-3-methylpentane, following the rules as previously given. Next are the alkyl halides. Halogens can also be on the branches. If we have fluorine as the branch, it'll be called fluoro. If we have chlorine as the branch, it'll be called chloro. Bromine will be bromo, and iodine will be called iodo. They follow the same naming rules as other branches. And these compounds, for example, will be called 1,2-fluoro-4-methyl-cyclopentane or 2-chloro-3-methylbutane. Now see for yourself why. Next are alkenes. Alkenes have double bonds and are named based on where the double bond is. Because they have double bonds, they are unsaturated with hydrogens. The naming rules for alkenes are the same as alkanes, except you use the ene suffix. The parent chain must contain the double bond, even if it is not the longest chain. And the position of the double bond is indicated by the number of carbons in front of it. And you want to number it so that it's the lowest possible. If there are multiple double bonds, then you represent that by putting the numbering prefixes di, tri, tetra in front of the ene suffix. Like with these. So this is one example with just one double bond. You see, I put the 3 in front of hexene to indicate that it is 1, 2, 3 carbons before the double bond appears. And of course, methyl appears as normal. With these two examples, we have 2 double bonds. We start counting from, we want the numbers to be the least, so we can't count from this side. And it's 1 and then 3, or 1 and 4. Pentadiene, because we have 2 double bonds. Double bonds, they can form different shapes. These shapes can be either cis or trans. These are called geometric isomers. They are alkenes that have the same structure, but have different orientation. So as you see with cis-2-butane, the CH3s are all on the same side, but with trans-butane, I drew them the exact same. They should not be like that. They should be like this. They should be on opposite sides. Next are alkynes. They're like alkenes, but with triple bonds, not double. So this is what ethene looks like. You see there's a triple bond. Propene, triple bond, butene, triple bond. Next are aromatic compounds. These compounds contain one or more of these benzene rings, which are essentially just cyclohexanes with double bonds for every other thing. When naming an aromatic compound, use benzene as the parent chain name. All of the other naming rules are the same, but if the benzene ring is a branch, then its name is phenyl. In these two examples, we have one where the benzene ring is the parent chain, and one where the benzene ring is a branch. Because of that, their names will be different in the full compound name. This one will be 1-bromo-4-chlorobenzene, and this one will be 2-methyl-1-phenylpropane. It's phenyl because it's the branch. And yes, benzene can also be drawn like a hexagon with a circle in the middle. We're almost done now. Next, we're talking about functional groups, which is basically a group which is an atom, a group of atoms, or an organization of bonds that react in a specific way. These functional groups include alcohols, I think you've heard of those, aldehydes, ketones, ethers, amines, amides, carboxylic acids, and esters. So here's an example. We have ethanol and methanol. They are similar because they both have this OH on the end. You need to be able to recognize these groups. This squiggly line just represents like a chain of hydrocarbons, and this just means it can attach anywhere in the chain. So you can recognize an alcohol by its OH, An aldehyde will attach to a carbon. The carbon will have one hydrogen, and then it'll double bond with an oxygen. That's how you recognize an aldehyde. An ether, on the other hand, will connect two carbon chains together with an oxygen in the middle. A ketone will double bond to a carbon, replacing two hydrogens. We have four more. An amine will attach to the carbon chain as a nitrogen with two hydrogens on it. An amide will do the same, except that carbon will not have two hydrogens. It'll double bond to an oxygen, and then it will attach to the carbon chain. Carboxylic acid is like an aldehyde, except instead of just having a hydrogen here, it has an oxygen and a hydrogen. This allows it to act as an organic acid. Finally, we have an ester. It's like an ether in that it combines two different hydrocarbon chains, but it's slightly different as it has a carbon and then a double bonded oxygen, which then connects to another oxygen to form that connection. And finally, you need to be able to know how to name alcohols. So the suffix of an alcohol compound is OL, and the number on the chain is given to the least number away from the OH group. So for example, here we have a 1-butanol, because it is one carbon from an OH. This one would be 2-butanol, because it's two carbons before you can go to an OH. And you always number the chain to the least number to the OH group. So this one, normally, if you didn't have the OH here, it would be 1 cyclopenene, or pentene, sorry. But because the OH group is here, it's actually 3 cyclopentene 1-ol. And in this one, you can also have the ditri prefixes if you have multiple OH groups. So this is 1,2,3 propane triol. And that was a not-so-brief overview of naming organic compounds.